I don't know. I know that all of you use the internet, for sure. Probably you got your ticket through the internet, but most of you probably don't know what telecommunications is. So I'm a PhD in telecommunications, which is that thing that nobody cares about. You only care about when it doesn't work. But basically what telecommunications is something quite similar to blockchain, right? It's a collection of nodes that together form a network. And these networks send messages across each other in the form of protocols. You may know the IP protocol, for instance, which is what the internet is based on. So I'm very passionate about telecommunications, and I will tell you why. And if I have to leave to London tonight with one mission, is you care about connectivity more than when your Wi-Fi doesn't really work. So there are some numbers that tell you how important connectivity is in the world, right? Only an increase in 10% of access to fixed or mobile broadband across any type of economy in the planet would give you an increase of almost 3% on your GDP. The impact of an internet shutdown is incredibly large, 140 million pounds a day. And that can be happening, you know, when we have like the 3 UK shutdown none of you could access your mobile phones, or even AWS going down because they control 80% of the internet traffic. So it's not just one service provider that can bring these problems to all of us and society. The reality is that connectivity is not only important for us, it's also powering the entire economy. There is absolutely no corner of the planet where we can see the benefits of networks. And I just want to very, very quickly cover some of the really interesting things that I have had the opportunity to work on. This here, it is a robotic arm, and at the end of this, it has a sensor. So I went and I talked to that surgeon over there. He's a neurologist, and I asked him, what's your Christmas letter? What do you want if you could ask for anything? And he said, give me back my sense of touch. Because when I got into laparoscopic surgery, I lost my touch. You put all these little things inside your body. Yeah, you recover in 2 days from a surgery, but all of his knowledge is in his hands. The tactile part of his palpation was lost. So we created this sensor. Well, we don't. The robotics department of King's College London created this sensor. And what we did is we connected it over a 5G network. We put 360 cameras so that we could immerse the surgeon inside of the body. And what this robotic sensor was doing, it was going to generate a tactile signal that was going to be different depending if it was touching cancerous tissue or not. Obviously, this robotics department was also working in medical robotics, so by computer vision, they could understand if there was a tumor or not. But we could translate that into signals that then the doctor could feel in their own hands, and therefore that was in the form of the prostate. Instead of removing the entire prostate, it could literally just cut where the cancerous tissue was. So then we moved it into an MRI form, and how can that same surgeon, as soon as the MRI is out, can put it into what is a VR environment and move that MRI, and through the same tactile glove, understand where they are touching and where is he going to find the cancerous tissue. And that you can train anyone globally using the internet, a very, very fast internet. The last example over there is actually something that we did here in the Greater Manchester area in Salford. In the A6, Chapel Street, which most of you know, there's a lot of traffic. And traffic means productivity. The faster you arrive to your office, the faster you arrive to class, right? So we connected the traffic lights to AI sensors. And with those AI machines, what they are doing is they control when the traffic lights are red or green, or promotes active travel, any type of policy that it wants to promote by the Transport Authority. Those devices go connected to the internet, I bet you guess. But when everyone gets out of their offices and it's like 5 p.m., that network gets really, really congested. And you can't have really having those traffic lights connected to a network that it's actually not really working. So what we did, we connected it to a 5G private network that was owned by the Transport for Greater Manchester and gave access to this technology completely isolated to what the connectivity that you use for your phones. So that is where diversification actually played a key role. We needed a network that was not owned by the service providers, that was owned by someone else and was providing a service. And that brings me to how networks are built today. Very simple. I'm going to explain you the horror of the telecommunications industry. We have a bunch of companies that I'm sure you know all build very expensive equipment. We have a bunch of companies that I'm sure you all know because you buy SIM cards, and they decide where these networks get built. And it's based on wherever they're going to make money. And then they distribute the services and we consume the services. So, well, the impact of not having connectivity, I'm not going to go through this, but I'm sure you know, very high. And where do we come in with the blockchain layer? So this is the established, the vertically integrated model that we call. It's one network, one provider, then the consumer. Everyone owns its own network. They decide where it goes. This is what we are doing. We believe that networks can be built as a combination of assets that many other providers can build. So for instance, this building can own its own network. Then the city council can own its own network. The shopping mall can own its own network. And there you go. And guess what brings it all together? Blockchain. And then on top, we have the services. And then on top, you can provide your decentralized services. So what we are actually doing is we are decentralizing the ownership of the internet by incentivizing the contributions to the network, by incentivizing the contribution to the actual infrastructure. You can look at apps. Weaver Labs, we build CellStack. It is a product that what it does, it uses a distributed ledger-like technology like blockchain to add all of these assets, create a network of networks that then is opened up to be consumed as a service. So to the owners of infrastructure, what we tell them, we make you money fast because your infrastructure can be discovered and then it can be used by the use cases and by the service providers. And to the service providers, we tell them, don't be greedy, share the infrastructure, use the infrastructure that others have built. And then we can decide who decides what value is. If I'm a local authority, connecting the unconnected might seem value. And this is the world with a decentralized physical network. You can have all your other players who were building networks before, and now you can have other players who are building networks now. Building owners, office spaces, cities. Then you have us aggregating all of that with a distributed orchestration tool. Orchestration is an IT cloud term, but it means it basically connects software together. And then blockchain, all the assets are available there in the form of a marketplace, and then services sit on top. Very simple, right? I hope you do care a little bit more about connectivity now.
Okay, go on guys, go and get your change.